Yes, here we are talking about P series, and let us open this series. Here it is 1 to the power P. When we are talking about when n equals to 1, when n equals to 1, what we have? When n equals to 1, at here in the series we have 1 over P. It starts from 1. That's why that I think first of all when n equals to 1. 1 over P is 1 plus. Okay, so we will add it later. When n equals to 2, let us think what happens when n equals to 2. It is 1 over to the power P. Okay, so P can be, if P is a positive number bigger than 2, then this series converges. We are going to talk it. This is 1 over 2 to the power P. This is 1 over 2 to the power P here. And when n equals to 3, here when n equals to 3, we have series like this. We have 1 over 3 to the power P. We have 1 over 3 to the power P. Okay, so this series okay, so let me write the series again. This series symbol is this one, okay, and it is from n 1 over np, 1 over n to the power p, 1 over n to the power p, 1 over this is p, okay, and the borders, it starts from 0 and goes to, it starts from 1. Here it starts from 1 and goes to infinity. That's what it says. It starts from 1 and goes to infinity. Yes, this series, let us write the first 3 terms. The first term is 1 plus. The second term is this one. This is the second term. And plus the third term is this one over here. This is the third term. Where's this P? Okay, and it continues like that. Okay, so this series continues like this. So in this series, when we have P bigger than 1, this means that here when we have our series, when this is a series like this, and this is a series like this, when P is, let us say 2, okay, when P is 2, then this series converges. When this power, when this P is 2 here, then this series converges. Okay, so you have to know that whenever you see a series like 1 over n to the power 3, 4, 5, 6, 7, it converges. So this converges. Similarly, this converges when it is 3. What it means, it reaches to a number, okay? It converges. So this is 3, okay? This converges. And whatever it is, it's not important what we have here. These are P series. And here, even it is 4, 5, 6, just one more example, these all converges. The only rule is that we have this P bigger than 1. Okay, this converges. Which ones diverge? When these numbers, but here when these numbers are smaller than and equal to 1, even it is 1, it diverges. Okay, so here when I have minus 1, okay, or let us say minus 1, this diverges. So whenever this here is smaller than 1, they diverges. So here this diverges. So you must be able to interpret this in this meaning. Be careful. So it will be an open book exam. I don't want you to know them by heart. Just I want you to know what are they, how we can open this like this terms. These are first three terms, and to know what divergent or converging means. Yes, these were P series. They are now root tests. Okay, this is A N. Let me open this root this series here. This A N series. I'm going to open a new blank page. Okay, the old one. Oh, I can. I'm trying to arrange my page and maybe get this smaller. Okay, so in the root test, I'm going to make this smaller to see this right here. Okay. So here we have another series here from 1 to infinity. Okay. So here, no, sorry. So this series from n equals to 1, from n equals to 1 to infinity. Okay, so in this series it says an. So I'm going to write here an. So these type of series are A1, A2, A3. In this type of series. The condition for convergence is we find root, square root, nth root. If it is n, we find nth root, and if it is smaller than 1, then it converges. It is bigger than 1, then it diverges. Here there are other comparison tests, but we are not going to see them, and I'm going to open this one. So here, test for divergence. If limit as n approaches to infinity goes to 0, yes, so we have to check it. No, if it doesn't go to 0, then it diverges. So in this type of series an, if it is equal to 0, if it is not equal to 0, then the series itself diverges. Okay, so I'm not going to show these ones, and I'm going to open some other tests. Okay, so this series, the first term, second, third, and this is first term A1 term, and this is A2 term A2. And this is the third term of this series. This one over here is A3, third term of this series. Okay, and this is nth term. Nth term is just this one. Okay, so what about an plus 1 term? So let us find it. An plus 1. So this is n plus 1 term. So we are going to write here n plus 1 to each n. Every n will be n plus 1. So instead of n, I'm going to write n plus 1, n plus 1, okay, and here n plus 1, and here I'm going to write n plus 1, as you can see, okay. So this is n plus 1 term, and this is n term, an term. So here, in this question, okay, so in this question, what was a n plus 1? This was a n plus 1 that we have just found. We have just found this is a n plus 1 first term, and this is divided by a n. You know that when it is divided, you change the order. So this is n factorial over n to the power n, and to solve this, you can separate it like this is this can be separated here. You know that this is n plus 1 here, n plus, this is n plus 1, this is n plus 1, multiply by n plus 1 to the power n, to the power n, n plus 1 to the power n, to the power n, yes. So I separated that, this is just power, I separate this power here, and this can be separated, you know, this can be n plus 1 multiplied by n factorial, because this is factorial, and in this way I can this and this can be omitted, deleted, you know that this and this can be deleted, okay. And what we have afterwards, let us see. And here we have this one. Look. Here this is n factorial, so these are gone. Okay, so these are gone from here. This and this are cancelled, and this n factorial, and this one is cancelled. So what we have is inside pictures. Just a moment. So what I have is just, this is not tick. Okay. So what I have is this one and this one and this one, because all the others are cancelled. You see that this one and this one is cancelled, and same with the other ones. This one and the other one is cancelled here. This and this. Okay, so these are cancelled. These are cancelled. So we have n plus 1 to the power n over n over n. And here we can write it as 1 plus 1 over n to the power n, and this as n approaches to 0. Here this is a divergent series by the ratio test. What was the ratio test here? Let us look. The ratio test was somewhere here. Therefore, so ratio test is here when limit as n goes to 0, a n plus 1 over a n is smaller than 1, then it is convergent. And when it is bigger than 1, then it is divergent. So that's what we say. in this series questions. This example also. In this now this is an a to the n. You can think this as a, okay? So it looks like this this here root test that we can apply this root test. Look, they are same. So it starts from 1 to infinity. So let us look to limit as a n plus for 1 term over a n, whether it's smaller than 1 or whether this is bigger than 1. So in this question, let us look to this equation over here. So this term, okay, so this is a n. Okay, here the root test is applied. So we can do that also. Here it's take the nth root. So when you take the nth root, this is cancelled. You see that this is nth power. So you can directly see that. So it here what it did. Let us look here. This is not this one. This square root. Yes, this is applied. Okay. So why this is applied? Because since there is a power and it seemed easier in that way. Let us compare two questions and let us see this question, the fifth question here. In this fifth question, we cannot directly omit this n when we take square root. We cannot omit it. And when we try it this way, we see that it is simplified. And that we see that it reaches to e, and which is bigger than 1, therefore it is a divergent. However, here in the sixth question, when we look at here, when we take square root of when we take nth root, not the square root, when we take nth root, here when we take nth root, this is nth root, this is simplified. We only have this one, and here by dividing n, both numerator and denominator, we have 2 plus 3 over n, 3 plus 2 over n, and we see that this approaches to 2 over 3. As limit as n goes to infinity, this approaches to 2 over 3. 2 over 3 is smaller than 1. So what was our rule for the root test? When it is smaller than 1, then it is convergent. So not only these two geometric series, P series, we had a question with root series. Why we use this root series? Because it is easier here, because it just has an n here, and we take nth root, it is directly simplified.